Okay, welcome back everyone. In this example we're going to look at how to apply the wave speed equation. So that's v equals f lambda, and this is example problem 75 on page 464, and in this we're talking about using sonar or sound waves to kind of figure out the depth of the ocean. And I was actually reading yesterday about some island where you go scuba diving and the ocean floor starts about 1,000 feet deep, and then all of a sudden it just drops to several miles. So it's kind of interesting, kind of scary, because I guess if you're scuba diving it goes from nice bright blue over here and then it's like pitch black when you look down. But anyways, the frequency that we're given for these waves is 2.50 megahertz, which is the same thing as 2.50 times 10 to the 6th hertz. We want to convert before we calculate. The wavelength we're given is 4.80 times 10 to the negative 4th meters, and we're told that it takes 10 seconds for the sonar to reach the bottom of the ocean and to reflect back upwards. So without factoring into account that the wave speed changes slightly, we're going to ignore that and just use our wave equation here. So what we want to find out is the depth of the ocean floor at that point. And since we know that v is equal to f lambda, we can calculate the speed of the waves is just 2.50 times 10 to the 6th hertz times 4.80 times 10 to the negative 4th meters. And just as a reminder, hertz is the same thing as 1 over seconds, so that's how we can say that this is about 1200 meters per second. Now, knowing that, we know that the distance the sonar is going to travel is going to be down to the bottom of the ocean, which is a distance of d, and then back up. So distance equals rate times time, and that means that the distance is 1200 meters per second times 10 seconds divided by 2, and we're talking about 6,000 meters, or the book says the answer is 6.00 kilometers. And that's pretty much it. The only thing that's tricky about this is making sure that we put everything into base units, so in other words 1 over seconds, and getting rid of the m in megahertz, and then making sure the wavelength is expressed in meters. Okay, we'll see you next time.